Hello, I'm happy to have you here again to the UI Test Automation Design for Efficiency webinar. I hope that you enjoy the music on the background and had a nice time before waiting. My name is Cotruța Bunia. I'm a test lead at Yonder, and today we are going to talk about how to make our test automation design more efficient. Why? Because all of us want to write tests faster, and of course, we want to spend less time on maintenance. As we noticed in the previous webinar that we had with the 13 lessons learned from test automation, in automation, we can face different challenges. Also challenges that maintaining our automation test suite. We may not be able to automate all the features. Sometimes we have a lot of duplicated code in our test, and we are adding a lot of technical depth in the design. Well, we know, all of us, that the test automation is living, breathing code developed to provide sanity checks in production code. And we need to find some ways to improve the accuracy, to reduce the maintenance cost, fasten the design, and improve its efficiency. And all those practices we are going to talk today, and hopefully you can take a lot of this information for yourself and learn new things today. This session, combining with the previous one, is a little bit more technical one. For those who are familiar with test frameworks and test design, you may find it useful today with some ideas that you can use and implement on your frameworks. But for those of you who are not familiar with the hands-on part, you can collect a lot of useful concepts that you can follow or you can share with the team. Okay. So before starting, I want to tell you my story in automation. So for this part, the automation journey for me started, I think, 9 years ago. And 9 years ago, my manager at the time told me that I need to create a test framework and I need to define some tests and present it to our customer. And I was so, okay, where to start, where to go, why I need to create a framework, how I need to create a test. I had a lot of questions on my mind. I didn't know exactly what to do. After I searched over the internet, I noticed some definitions, some ideas about testing frameworks, about how we can collect things and how we can structure tests. So I started to implement something and I started to understand something for that part. Not that much at the beginning, but still something that helped me. So before starting, let's see exactly what a framework is and what the framework does. So, okay. So the test framework, you can hear it a lot of time as being the test framework or test structure and more defined parts regarding this, how you can structure your test, how you can define your structure, something like this. All of these are represented by the test frameworks. They represent a set of rules and best practices, both from testing, but also from programming, which can be followed in a systematic way. in order for us to achieve the desired results that we want from our automation. We can include some rules or best practices like coding standards, test data handling, object repositories, access internal resources, and process for storing specific test results for our tests. The important function for our test framework is the fact that he has to be efficient in order for us to reuse the script, in order for us to perform some actions on these identified objects that we have in order for us to have a specific result. Well, there are a lot of articles about different types of test frameworks and how you can create it and what are the benefits for each of them. So the most known frameworks or type of frameworks that appear are the linear ones, which have all the codes together. Those data-driven, which are mainly based on data. The keyword-driven part. The modular framework, which is based more on specific modules that can be reused in the test. And we have DSL, domain-specific language frameworks, mostly used in agile parts for BDD tool integration. So this to clarify a little bit what the framework is, because we are going to talk a little bit about the framework during our entire session. How we can create our framework in order for us to have efficient results. Okay, to go back to my story, I understood something from the test framework. I started to write some tests. And I was really, really happy. So I was so excited that I was able to write in 1 month around 20 tests, and I was able to demo it to the client. And I continued in the same happiness. I think like almost a year. But after a year, I started to make retrospective over what I wrote and what my framework was, what my structure of the test was. Because I started to be not that happy for the tests which I've created. So why is that? It's because I found during the implementation of the automation test that I'm having a lot of bottlenecks, called like this. Some of the bottlenecks that I encountered was the misalignment of the coding standards. I did not define something that I'm going to use the same for the entire structure. I just wrote code and I did not have a specific coding standard. Of course, I did I'm calling it a lot of hard-coded data in our tests. So the problem was that when something was changed and something was missing from the product, all my tests were failing because I did not have appropriate test data, and that was a failure. The third one was that I was using the automation tool library code in the scenarios. And I had my code, functional code, and library code all together, which wasn't the best idea. And I will tell you a little bit about that in the presentation afterwards, because it's kind of a sad, funny story. I had a lot of duplicated code. So if I had the function to calculate and compute the current date, I was using it, I don't know, 4 or 5 times in my test. I was using a lot of functional calls and functional methods a lot, and I duplicated a lot of my code. I put the business and the technical part together. I did not use any modules for structuring it, so that I needed to redone a lot and do things over and over again. For simple tests, things were okay. But for tests which were a little bit more complex, where we need to use a lot of steps and we need to create a lot of cases, then the code was very fragile. There was a lot of failure because of that. So for me, the bottleneck was that I had a lot of time spending in maintaining of the tests, but also in writing them. That was the biggest, sum up all these parts. The idea was that I had a lot of maintenance time. I'm not sure how many of you faced these challenges when you wrote automation tests, but I'm very curious to see the poll after the end of the session. Okay, so it was something that I needed to change. I needed to create my framework because everything that I read, well, I haven't implemented everything. And I needed to start to create something better. I didn't manage to do it like that in 1 month, but I managed to do that in time on that project, on a different project. But I needed to have a more usable structure that I can rely on, and I can have less time spending in doing annoying things like maintenance, for example. So the benefits that gains and the benefits that I noticed in time that the test framework will bring us and a very well structured code base will bring us will be the fact that you have reusable functions that will make the test run fast and easy to maintain. The maintainability and the improved of the maintenance in time for the code and the possibility to change one single line of code and not change 100 lines of code as I did before. The scalability part, to be able to integrate it with different areas and to be able to make it scalable. The modularity in the idea that I would like to have different modules and I will have to make it separate for each of the main parts, main functional parts, to be able to add modules and remove modules. To be able to have something which will bring me the lower of the cost for maintenance and faster design. And in time, I learned that it's something that is very nice to have that will bring a lot of useful test design also for people who are not that technical once the framework is up and running. So those are the benefits that I can see for a test framework, especially the fact that I gain a lot of time in writing and maintaining the test. At the end, I will give you some percentages of how I found it during the experience and what are the benefits that actually bring that to design. Okay, so this is the part. What I'm going to tell you for now on, there are some concepts. And ideas which I learned during the automation part. There are some main ideas that can help us and that helped me, and I hope that is going to help you also. The most important part before starting a framework and before going to the actual technical concept, the most important part, as we discussed in the previous session with the 13 lessons learned, is the knowledge of the context of the product which we want to automate. That is very important because the business context, but also the context for the technical context will give us a lot of information about what and how we need to do in our framework in order to have success. And that's one of the most important parts. Another thing to mention about the concepts which we are going to discuss today is that those are generic. So there are generic concepts that can be used with any tool and with any programming language that you are choosing. So there are no restrictions, just the difference of implementing them, because yeah, if you're having different programming language, you can implement it a little bit different. But the concept itself can be reused on any framework. To exemplify some of the areas, I chosen to have C# with Selenium WebDriver. So for some of the areas. Okay, well, I will start with specific context, a specific situation. Well, most of you who are involved in automation, I think you know about what I'm going to refer in the situation. But some of you who haven't spent it and haven't looked already to this to this first concept, you're going to find it that it's the main and the most important concept. So. In most of the cases, when we want to implement tests, we end up in the idea that in the situation in which we want to automate something from the same page, and we want to create different tests on the same page. For example, that I put in the code here are two tests, one for the login with valid credentials and the other one for login with invalid credentials. The idea for all of this is that in order to do the scenarios, you are going to use the same data. So you're going to use the same data enter for the first test with the valid one and the second for the invalid one. And in such examples, multiple time, what we do is that we duplicate code. And this is something that makes us to have our tests which are not maintainable. We duplicate code because of the duplicated functionality, and we result in duplicating usage of the locators because we have the locators and the actions. The disadvantage of duplicating code is that the project will be less maintainable. In this case, if some locator will change some element, so this one is the first element for the username. If this one is going to change in time, then we are going to change, and the necessity to change it all in all the places where it is. And if we are having like 100 tests which use login, then we are needed to do this for 1,000 times. 100 times, sorry. So that's a lot of maintenance. The concept is called page object model. Then page object model is a design pattern that to create object repositories for all the elements that we have in the page. The advantage is that it's going to reduce the code duplication and improve the test maintenance. What it does contain, it contains the element locators, also called sometimes the UI mapper, and the methods that perform operations on those elements. All the methods that are going to use that. And if we are going to have the example, how we changed it and how we can change it with the page object model and how easy it is to reuse the code, is by defining a specific class. As you can see in the right side, the class is for the login page. So the idea for the page object model is that each class, each page in your application is going to have defined a class in your test automation framework. It's going to contain the elements which are going to be identified and the operations that are going to be made for each of those elements. For this, for better usage, an example, I used encapsulation to be able to access the class, just the actions and not also the elements. And another thing is to add parameters to the functions that are the actions that are going to use for the fields in order to be able to parameterize and use different test sets in the future. Having this in our test, you can see that the test is a little bit more clear right now because I'm having the login page and I'm having the dashboard page. And I'm going to create the object for my page. And with the object for my page, I'm going to access each method from my, my login page. And I'm going to provide a test data, which I would like. The code is much cleaner, and if I need to do something and change a specific locator, because that's a problem in general, I'm going to change just in the login page here. So that's the only place where I need to change it. And the change will go to all the tests that are going to use that function. So that's the benefit that is gained through page object model. This is one of the techniques, and this is going to help you a lot during your test. It mainly is the basis for structuring the framework. The second part is that if we are looking over the test, let's say for this one, we are seeing that we have a set of actions that are always executed in the series of actions. Like this, for the login part, we have the series with the enter username, enter password, and click on the login button. Well, the idea is that rather than writing those actions again and again in our test, we can group those actions into a method and then calling that method in our test script. This way, this is called a modular driven technique. And this part with the modular driven technique avoids us and gives us the possibility to duplicate not to duplicate our code. So for this part, modularity avoids duplication of the code. If there, in the future, if there is the case that something is going to needs any change, then that change will be done only in the modular method, and the scripts will remain the same. For example, we have the login flow as being our structure, and the login flow will have the method, the modular method, which groups all the other actions. In that way, when we are going to have our test in the right side, then we are just going to call our flow. Login flow.login, and we automatically log in for this part without adding all this specific data. If in the future we are going to have a separate way of handling this, let's say, for example, we have another identification for the login part, then we can add it only in the login flow method. So this is for the modular part. And the benefit is that exactly as a functional test, you group together a set of tests and then you are going to reuse it all the way. If the change happens, you're just going to modify the modular part and you don't need to, which is in only one place, and you don't need to modify it in all the places where you have a specific content. Okay, this is for the modular part. Sometimes, as in this case, you can see in this case and in the case that we had here in the previous part, we have used and declared some objects all the time for all the pages that we have. And sometimes it's more important to hide the complexity from the test and encapsulate the logic in the test automation framework. In this way, we are going to avoid object initialization in the test. So the concept for this part would be the page generator, which can be created no matter what structure we are defining for this part. The idea is that we are going to create a page who is going to generate some page objects, which are going to be totally independent of the test class. And what we can do with the page generator is the fact that in our test, we don't have to create a new object of the class type. We are just going to access it with page.login.method that we need to have. In this way, we have more clear tests. And in this way, it's much easier to follow in case that we are going to have complex tests that involve navigation through multiple pages. We can see easily on what page we are and without adding extra code for defining the object. So those three concepts that we discussed so far, the page object model, the modular driven technique, and the page generator, are mostly related with the structure of our object repository. One thing to add here, during my experience, I encountered different situations in which I use the same concept for page object model or modular technique or page generator, not just for pages. The idea is that you have, for example, for a page, you have the header and you are going to have the menu, for example. The header and the menu are going to be on all your pages. So I don't want to enter them in all the page objects. Or for example, you have a table, and that table, it's on 3 or 4 pages from your product. You don't want to duplicate it on all the pages that you have. So for this area, you can use page object model, modular driven technical page generator, not just for pages, but also grouping components or page sections. So if you have a component, just define the same thing that was just for that component, not for entire page. Or if you have page sections which duplicate in the structure, you can do the same. So you can use it for the page, also for components, or also for the page section in the structure. Okay. That's one of the contexts. The other one is related to the browser. So if we go to the next situation, what's happening in our test when we are creating the pages, we are passing our browser to all the pages from the browser. And what's happening in that way is that doing that and moving our web driver object across different tests is a duplicate process. And what's happening is that the complexity of our test increases when we need to maintain, and I'm sure that a lot of you were in this situation, in which you need to maintain only the one instance from WebDriver to the test run. So you needed to pass it from page to page and from setup to page, and that adds a lot of complexity. Also for this station, we duplicate the code by creating the structure and running the driver to our test. So we define the object for the driver, and we use the driver in all the new page instantiations. One thing to overcome this problem is to instantiate the web browser and maintain the instance for that in a small class that uses the factory pattern, which is browser factory pattern. And in this way, having this, it stores the provided different page objects for usage, and it's going to encapsulate the creation of the object. What I put here a small part of how I created it and how I instantiated in my test. Having the function for the init browser is actually the function, the method, the static method who is going to create actually the driver based on what type of driver we want to select. And we are going to change, and we are going to pass further on the driver instance to the driver variable. And this helps a lot by not having all the time to set the driver to all the tests. For example, when we have the before test part, the setup, well, we are just going to call the browser factory. We in the browser, we define the name of the browser. In this case, I hard-coded the name of the browser here. And we're just going to call it, and then in that mode, then we are going to have for this part called, and we are going to have the Chrome driver, which is going to be instantiated for this part. And when we need to run in our setup the test, and then for that part, we are going to provide it the web driver, and we are going to give the value for the driver for here. So we are going to use this part in only 2 or 3 sections from our framework, and not being able to send it for all the tons of classes that we are going to have. Okay, this is for browser factory. Now I want to go back to my initial story. And tell you that part that I mentioned to you with the library for the UI test. And it actually was funny because it passes like, I don't know, 8 or 9 months. Still I started to write tests, and I was around, I don't know how, I had some quite coverage. And in that moment, I was writing the test using Selenium 1. because it was just Selenium 1 at that moment, not also Selenium 4 at this part. And I was writing the test using Python, and I was very happy. When Selenium 2 appeared, I said, oh, okay, it had a lot of features, it was easy to use, so I needed to use it in my tests. So I tried to use it in my tests. And the problem was that when they launched Selenium 2, they provided a binding to be able to use the old test from Selenium 1 with a test from Selenium 2. And yeah, that was another good point. But the idea was that that binding was only written in Java, and I had the code in Python. And I couldn't do anything. The only solution that I had was for me to rewrite the tests, to rewrite all the tests, to include the new library, which added me a lot of refactoring and a lot of maintainability in the test. And that I think was a lessons learned, because from that moment on, I never did that again. So the new pattern which I want to tell you, and beside my story, and the large effort that I needed to invest there. There are situations in which the library that you're using for your tool does not function as well for all the APIs. For example, for saying keys, when you write tests, you want also to clear the test from the field, or for the click, you want to have hardcode tests, you have to have multiple clicks, or it does not function, so you need to use the keyboard in order to click on an element. So that's also adding the data. Or you don't want to have a lot of duplicated code when you add error handlings each time for the elements to check if they were found or if they are not found. So this situation and my situation that I was telling you about goes to another part that I've called and put it like web element extension. Web element extension is enables you to add methods to existing types without creating new derived types. Actually, those extensions are wrapper over the initial Web2 library. In order for us to be able to have clear methods, to be able to use our methods much easier in our tests. So to give you some example about this, for me, the idea is that all the time when you're using a library, do a wrapper over that library. In that way, you won't have any problems when you update your test, or you don't have any problems when you change the library for the tool that you are using. So that's one of the things I learned on the hard way, and which all the time gives me benefits and joy for that. So what we can do for this part, so you can take each of the elements that you're having, all the type of elements, and for all the type of elements, create an interface that is going to highlight what methods you would like to have for that specific element. Once you have that, you go and you implement the class for that, you implement the interface. And you do all the tests which are necessary. For example, enter test, which is the classic wrapper for over keys, will have a generic method to ensure the element exists. Well, the ensurement of the element exists is going to check if the element's on the page, but in the same time, it's going to add an error handling in the function to handle that. Then you clear the element and then you enter the text actually. And another part is that you can do this for each of type of element you're having. But besides this, you can create your base element, the class, which will contain all the other actions that you can do over elements, which are generic and can be applied for all the elements or all type of elements that you're having in the page. Okay. So this is the wrapper over the element actions that you can have with your tool. We know you have the browser, and of course we have some options for the browser. So we can have an iWeb browser, the interface, defining what methods we want to use in order to access the browser, like navigate to a specific page, refresh, accept, close, things like this. And also to implement the web browser and to define all the methods which we declared. This is the one, the second one. And the third one who remained is the part and the wrapper over the element finder. In Selenium and also in most of the tools that we use for the UI part, we have driver.findElement by XPath or by ID or by something like this. And this element finder is a wrapper over that part in the idea that we have the interface for handling this for all the elements that we have, and we have the wrapper for each type of element. The idea is that in this way, we are not going to have any control part in our page object model. So we are going to define just some folders in which we handling the setups and we handling the hard structure. And we are not going to use it in our page objects, in our tests, anywhere else. We're just going to isolate it further on. And when you use it in the page objects, we can have it something like this, which is going to be element finder.text or .button without specifying the driver and without using actually the library that we are using. So this is the web element extension part. Okay. So we talked about a lot of patterns so far. If we are going to implement it in a page that in a product that has 10 pages, then we had a lot of code right now. And sometimes our framework, well, is composed by these patterns that we discussed with the setups, with the tests, with the business, with the configurations, and so on, that is hard to follow. The second part is that we have some framework solutions that we want to use for other frameworks as well, not just for the framework we defined. And other situation is that we have multiple applications, actually multiple pages, multiple products to test in the same solution. Which some of them can be dependent one over another. So we are going to use the same, let's say, the same control level, the same libraries over each one. So the solution is, in our automation, to have an abstractization layer. So to have, well, they say that a good testing framework have layers. So to have like separate different projects or handling different aspects that will be grouped in 3 areas. One will be the control part for setup, for configuration, for control types, and also for the wrapper that we talked about with the control methods. The other one for the business level, which is going to provide you some object repository, functional methods, and so on. And the test level, which is going to contain actually the test, the functional test classes, and the test data, which is associated to it. This is the abstractization layer. And of course, the reporting part. It's hard sometimes if you don't have a reporting part to be able to execute and to be able to see your test. So for that one, a reporting is necessary to your test. There are different libraries that you can use for this part. I, for one, when I'm writing code for Java, I prefer an HTML report, which is the generated, an HTML report which can group and which can give me the overview over all the tests which pass, fail, and can automatically create and automatically generate some reports. And also integrate loggers into it. Well, for Java and C#, I'm a fan of extend reports, and you can easily integrate it, just some hacks, additional hacks to do with the library. But you can define nodes, create tests and results, and you can add also loggers. So in the right side part, I put an example where you can add logs. So you can log specific actions or specific data or specific methods. Another thing that I used to do is to log also screenshots in case the test is failing. This is because it's easy for me to see exactly the page where you failed, because sometimes you don't need to redo the test manually. You're just going to take a look over the screenshot. This is the reporting part. Well, given so, to make a sum up of the most important and most used concept on my side, I will come to page object model with the modular driven technique, page generator, browser factory, web element extension, project layers, and test reporting. You can also have different others concepts. I think we can talk about those a lot. Utility functions for the constant method of constant variables that you're going to have, or for the messages. For example, if you have a lot of messages in your application, you can put all the messages separately, so you can access very easily and update them very easily, not use them hard-coded in the code. Utility functions, configurations to be able to take the URLs from the configuration files. Data-driven techniques and data-driven structure, error handling separate from your test to be able to use it in your data. The idea that all the tests should be independent. So to not forget about that. Naming conventions, screenshots on the failure, and integration with the CI a tool that needs to be part of the framework itself at the whole. And I will be back a little bit now on my first story. So we talked about the benefits of automation and the framework, and the idea that we have reusable functions, ease of maintenance, modularity, and so on. What helped me in that way after I started to create the framework, or during time when I had frameworks to define, what I had is the idea that the test design time increases with 40–50% because you have the framework in place, because it's very easy to reuse and very easy to find items. Maintenance in time from 40–70% that were before, without having a very structured framework for the automated test, went to 5 or maximum 50% time when we have well-structured framework in place. The most maintenance was when the flows were changing, not the UIs and the structure and so on. And another important part, another benefit that I see in that if we have a very structured framework, you notice in the test how nice the methods were looking. It's very also easy for a tester which doesn't have a very strong programming skills to be able to write some of the tests. The simple tests or to run the test is very easy to involve them once the structure is defined. So all of these three parts are very important and add a lot of gain overall. Of course, something to mention is that writing the test framework at the beginning and finding the best solution can be a little bit hard and can be a little bit time consuming at the beginning. But afterwards, you can collect all the benefits. Not structuring the tests will be more and far more expensive. Those are some of the main concepts, high-level concepts that I've used in creating test automation framework. I'm happy that you joined. I'm really anxious to see what experience you had in this area, and to hear and to I don't know, to discuss stories and compare specific notes. So if you want, and we can discuss further on, you can contact me, you can send me an email. My email address is kuduta.punya@tss.yonder.com. So let's see if you have questions for this part. Okay. Thank you, Tiberio. So if you have questions, don't hesitate to put them in the list. Or if you don't have right now questions, or if you find further on some questions, then please don't hesitate to write. Okay, thank you. Thank you. See you next time. Bye.